In this section, we need to remember all of the rules of exponents that we learned in Chapter 4. So this first clip is going to review those rules for us. The first rule we learned was the add exponent rule. If I have a base to a power times the same base to a different power, I'm going to add the exponents. So I'm going to simplify this expression to be a to the 7th. If I am raising a power, a to the 3rd, to another power, the 4th power, I'm going to multiply the exponents. So I'm going to get a to the 12th. If I have a product inside of parentheses to a power, I call this the share exponent rule, because I'm going to have 3 to the 4th and a to the 4th. But 3 to the 4th power is a number, it's 81, so I can simplify to be 81 a to the 4th. Two new rules that we're going to add into here is what happens if you have a fraction to a power. That rule is going to say you, again, share the exponents. 3 is going to be to the 4th power, a is going to be to the 4th power, so this will be 81 over a to the 4th. Share exponent works whether you're multiplying or dividing. The last new rule is a subtract exponent rule. And the reason that this rule works as it does, if I have a to the 7th over a to the 3rd, a to the 7th is 7 a's on top, 4, 5, 6, 7. A to the 3rd is 3 a's on the bottom. These will cancel, these will cancel, these will cancel, and I'm left with 4 a's on top. So I'm really just subtracting 7 minus 4 to get the power of a. What is 2 to the negative 3rd power? Well, before we can really try to figure out what this is, we need to answer the question, what is a negative exponent and what does it represent? So I'm going to look at some regular powers of 2 that I do know and see if I can come up with a pattern to get into what a negative exponent is. So I'm going to write all these powers of 2 that I do know and see if I can follow a pattern to get into these negative ones. 2 to the 3rd power is 8. That's 2 times 2 times 2. 2 to the 4th power is 4. That's 2 times 2. 2 to the 1st is just 2, because I only have one 2 there. Now to get 2 to the 0 power, if you remember from the exponent section, we know that it's 1. But I can also see that it's 1 by this pattern here. If I start at 8 and I want to get to 4, I can divide by 2. If I start at 4 and want to get to 2, I can divide by 2 again. 2 divided by 2 gives me this 1. So there looks to be a pattern of dividing as I move down this column. Well, if I divide as I move down this column, these exponents, let's try that again. If I divide by 2 as I move down this column, I notice that in this column the exponents go down by 1. So it seems that by going down in the exponent, I'm actually dividing by the base. That would make sense because if I look at what 2 to the negative 1 power is, it's 1 divided by 2. It is 1/2. And if I divide by 2 again to try to figure out what 2 to the negative 2 power is, I divide by 2 and get 1/4. Take 1/4 and divide it by 2 and I will get 1/8, which is 2 to the negative 3rd power. Whereas positive exponents are repeated multiplication, negative exponents are repeated division. But if I know what the positive exponent is, let's look at 2 to the negative 3rd power. I know that 2 to the 3rd is 8. 2 to the negative 3rd is 1/8. Let's see if we can generalize that pattern. I know that 4 to the 3rd is 6/4. Then 4 to the negative 3rd is going to be 1/64. I'm going to divide by 4 3 times, and in here multiply. Okay, let's try to evaluate a few negative exponents. 5 to the negative 1 power means we're going to divide by 5 one time. I would think of this as 1 over 5 to the 1st power, which is just 1/5. If you try this in your calculator, make sure you give me an answer as a fraction. I will not accept 0.2 on any test or quiz. 3 to the negative 2 power means I am dividing by 3 twice. That's 1 over 3 to the positive 2 power. This is 1/9. I'm just thinking of what is 3 squared and making sure that I put 1 over that number. 2 to the negative 4th power is going to be 1 over 2 to the 4th. I'm going to divide by 2 4 times. That's going to be 1/16. 1 to the negative 6th power, that means I'm going to take 1 and divide it by 1 6 times. Guess what? It's still 1. Notice, none of these answers are negative. The negative power just makes you divide instead of multiply repeatedly. All right, this next question. 2 to the negative 3rd to the negative 1. I'm going to use the multiply rule. So this is 2 to the negative 3 times negative 1 is positive 3. I have a regular normal exponent, so this is just 8. Here I'm going to use the subtract exponent rule because I'm dividing. I'm dividing 3 to the 1st by 3 to the negative 2. So this is going to be 3 to the 1 minus negative 2 power. 1 minus negative 2 is 3. So this is 27. This next problem, I'm going to use the share rule. Everything on the inside is the power of 2. So 3 to the negative 2 power by multiplying this one to the positive 2 power. I subtract the exponent again, so I have 3 to negative 2 minus 2 will be 3 to the negative 4th power. 3 to the negative 4th is 1 over 3 to the 4th, which is 1 over 81. Simplify using only positive exponents. This first one is already simplified, but I cannot leave my problem written with the negative exponent like this. I'm going to remember the exponent rule that says x to the negative 2 power is the same as dividing by x 2 times. So I'm basically just flipping the negative exponent into the denominator and making it positive. That's all I had to do in that problem. Because the 3 and the x is in the parentheses in this one though, I have a little bit more work to do. I'm going to start by sharing the power. Then I realize that both of these have negative exponents. They must go in the denominator. 1 over 3 squared is 9x squared. Right here, this is a subtraction rule. I'm going to figure out that the power of y is 3 minus negative 5. That means it's y to the 8th. Because my answer is a positive exponent, I don't need to put it in the denominator. This last problem, I'm going to use the add rule first and get a to the negative 3rd power. And if I square that, I get a to the negative 6th power. Because a to the negative 6 has a negative exponent, I need to rewrite it so a is in the denominator. Now it has a positive exponent.